Non-deterministic. Finite automata can be either deterministic or non-deterministic. But non-deterministic is more natural. For example, in natural language processing, a sentence could have many different parse tree, syntactic parse tree. And because language has ambiguity, and you can see my playlist for context-free grammar to see why this occurs, and or different playlists that I've created about natural language, that you will see that a sentence can have many different parse trees because the language is inherently ambiguous. So non-deterministic thing is more pragmatic, more practical in our applications in artificial intelligence. Or it's like control system. In a control system, if you give different inputs to your robot, you have different trajectories, and so depending on that, you have different trajectories. So it's not fixed. It's not fixed that you always say one given input. So even if you fix some given input, you will see that because there is a noise in the system, sometimes it behaves like this, sometimes it behaves like this, and sometimes it behaves like this. So we add a powerful and intriguing feature to finite automaton. This feature is called non-determinism because we want to cover many different languages. If you just focus on deterministic thing, you cannot cover general languages, and you will see how. And is essentially the ability to change the state in a way that is only partially determined by the current state and input symbol. That is, we shall now permit several possible next states. Several possible. For example, you start with state Q0, you have several possible next state. You either go to Q1 or Q2, even with a simple input. You may go to a different state. And so such non-deterministic devices are not meant as realistic models of computers. They are simply notational generalization of finite automata, and they can greatly simplify the description of automata. So for example, you go from Q1 to Q0, and Q0 is your finite state. So this is part of your language. What else can you do? You start from, for example, Q0, you go to Q0. Sorry, for example, you are in Q1, and you go to Q0, so it becomes B, and then you come back to Q1, it becomes A, and then again you repeat this. So this is part of your language. Another trajectory could be you start, for example, in Q1 again. You give B, and then you stay in, for example, Q0 A forever. So this is another example. So L is accepted by simple non-deterministic device, and so when the device in state Q0, for example, when the device is started in Q1 and the input symbol is B, there are two possible next states, because as you see, you either go to Q2 or Q1. So although B is the same, but you may either enter Q2 or Q0. So this is a non-deterministic device, which is very natural. And we also allow the state diagram of non-deterministic automaton arrows by empty string E. This empty string E is very important. From Q2, this machine can return to Q0 either by reading an A or immediately without consuming any input. It means E. This is empty string. It means even if we don't have any input, we will go in the next time step to state Q0. So this is a definition of non-deterministic. As usual, we have K is finite states. For example, K could be Q0, Q1, Q2. For example, we have 3 states here. Sigma is your alphabet. For example, A, B, all of these things, A, C, A, B, C. S is the initial state. For example, you start from Q0. Q0 is your initial state. And Q1 could be your final state. So you go to here and it is accepted. So if we say A and then B, so A, B is part of your language because it is accepted. If you go A and then B, or A, B, B, this is also accepted. Or A, B to the N, anything. So this is your language. And so each triple is called a transition. Because you are in state, you have in some state, you have some input, then you go to state P. So it's a transition from Q to P using that input that you receive. So in this example, for example, a string is accepted if and only if there is at least one sequence of moves leading to a final state. For example, B, A, B, A, B, A, B. You will see that how it occurs. B, A, B, A, B, A, B. Or any other path. So it is a non-deterministic. And so E plays an important, this empty signal. It means that no matter what happens, if nothing happens, you go to another state. So this generalizes some non-determinism.